Good afternoon, sir.
Let's say join first and then after I will start. Yes, had has joined actually. And and regarding the feedback form, I will create a Google form to all of you. Okay, for all of you, and I'll circulate it as soon as possible. Most probably by 8 p.m. today. Okay, when all the session will end, at that time I will give it to you all. Good afternoon, sir.
Good afternoon, Shantanu. Uh,
Yes.
am I audible?
Okay. So good afternoon to all
Shantanu,
the dear
I
participants.
was
First of all, I would
wondering
like to
if I share.
yes, sir, share the PPT, na, sir.
Yes. To
The
continue,
voice
if you
tech break.
complete, then
Yes,
I'll get
yes,
some help
yes,
from
yes,
you.
yes,
Share the PPT. Okay, okay. My
yes, sir.
voice is
Yes,
breaking.
sir.
Okay.
Definitely, sir. Definitely. Okay, 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 sir. So first of all, I would like to thank Professor Tapos Kumar Saha, and I would like to pay my gratitude for accepting the invitation in such a short span of time. Professor Tapos Kumar Saha joined NIT Durgapur in the year 2001, and presently he is working as a professor with the Department of Electrical Engineering in NIT Durgapur. He completed his PhD from IIT Kharagpur in the topic of power electronics and drives. His research area includes electric vehicle, electrical machine drives, wind energy conversion system. He has authored two well-known books with Pearson edition on the topic of digital control system and its analysis and its design. He has received the University Medal for securing first class position in the BE examination in year 2000, in year 1997. So, ladies and gentlemen, please welcome Professor Tapos Kumar Saha from NIT Durgapur. Welcome you, sir.
Thank you, Shantanu. Um, there may be little bit problem from internet, uh, for which
Yes,
I am asking little bit in advance. I'm asking this permission from you that there may be some disturbance from our end, and I'm not very much convenient with this
no issue, sir.
platform also. No, it is true.
Yes,
We
sir.
are
Yes, sir. Yes, sir.
working with
Told me, sir.
normally Google Meet or MS Team in NIT Durgapur. So um, I just want to know when I am sharing Shantanu my
Yes, sir.
presentation and going
Yes,
to
sir.
full screen mode, uh,
Yes,
just
sir.
check it is available or not. Huh? I'm sharing.
Okay,
Please
sir. Okay,
check
sir. Okay.
and let me know. After that we can start.
Yes, sir.
Screen, na? I will share screen.
Thank you,
Okay.
sir. So, we have got
It is telling connecting. Yes. Share. Oh, share. Yes. It is there, na?
yes, sir. Yes, sir.
Shared. Now, if I share,
Yes, sir.
it is
Ask
it is
sir. Ask.
also visible. Okay, wow.
Yes, sir. Yes, sir. Yes,
And if I
visible,
take
sir.
this, now also it is coming
Yes, sir. Yes, sir. Now also it's coming, sir.
full screen mode.
Yes, sir. Yes, sir.
Okay,
Coming, sir. Coming. It's coming, sir. It's proper
okay.
only.
And will there be any video of this session?
Yes, sir. Yes, sir. We'll
Recording will be there,
have. Yes, sir. Yes, sir. Yes, sir.
so we can check that one later, na? Okay, very good.
Yes, sir. Yes, sir. Yes, sir.
Okay, so uh,
Thank you, sir.
just 1 minute. There. Okay. I'm starting. So, welcome you all. I am not. I'm to start this session. Um, we do not know that in what context you are getting this interest in electric vehicle, but this is one area where lots of works are happening. So I will be very happy to be introduced as one learner in this particular field. Uh, the main reason behind that is because uh, we are not enough experienced in this field by now. Huh? In India, it is a little bit new also. So if you have any confusion, you can interrupt me and tell me, or you can tell me at the end also. No problem. And if there is any confusion in the broadcasting system because of the network or anything, Shantanu or any other team member, if can call me also over phone so that I can manage somewhere. Now, this is my topic. My topic is energy management and control of the hybrid electric vehicle. See, in hybrid electric vehicle, when I'm telling hybrid electric vehicle, we are moving little bit away from the actual topic of this one because not away, but we are bringing one new dimension to this one. Maybe we'll be having different types of lectures on these recent trends. So, and I will come back to you also after 3 days. Meanwhile, you will be getting many other ideas. But hybrid electric vehicle is a very interesting one. We will come to know why it is hybrid is necessary. But electric vehicle is the thing for which you are here. And energy management and control are two very, very important areas for electric vehicle. And when it is hybrid, the energy management is very much necessary. Okay? So this is our outline where we will be checking few things, introduction, then what is happening now, how do we classify, and what we feel there will be in the future, and whatever the schemes available, and the powertrain, and its modeling, and finally some proposal of hybrid storage and its application. Now, when we think about electric vehicle, you can see all world regions now is having this vehicle application because um, because of many reasons in introduction also we are telling why electric vehicle is coming, but this is the uh, picture which is telling us what are the different type of vehicles are there available throughout the world. Okay, we are also bringing in India few of Indian vehicles, though you will not get much at this moment. Started, it has got some uh, push also from policy point of view, but still it requires a lot more in future. Now, when we are talking about these vehicles and the future, then we must know few things. The first thing is that today world is burning. Burning, it is not just I'm telling it is burning from some feeling. It is the truth that because of this climate change, it is not a simple word. It is not coming in bracket, and you can ignore it for some time. It is not like that. Presently, it is not like that. These references here, but we all know few things about climate change. Is that in last 14 years, papers are coming every day. In last 14 years, the trapped heat in this globe is double of that one which was there 14 years ago. So you understand that how quickly we are capturing this information. Yes. Any problem there? Is there any problem? I hear something. Okay. So, so where we are talking about this climate change, you know? And this trapping heat, what it is doing, it is changing the entire phenomena of the globe. In this context, if we think about reducing this greenhouse gas, which can bring some change, then we are actually talking about the demand of this time. It is the demand of this time. Now there is a demand for future also. We will come to that one gradually at the end of this or my second presentation also. But the truth is that when you are thinking about reduction of greenhouse gas, reduction of uh, CO2 for some way, by some way, then the traditional conventional transportation sector cannot be continued because transportation sector amounts a large portion of greenhouse gas emission. Large means, you know, it is for some countries it is more than one fourth of its total pollution, more than 25% for some countries. For if you take globe wise also, it is very high, very high, considerably high even because of the emission from the burning of the petroleum. It is one very big problem. Another big problem is there, not only because of climate change. Another problem is that your petroleum resource is the amount of resource is going down. And going down, there is one term which is not mentioned here, but it is known as peak oil. If you can search, or you can, if you are aware, you know it. That already we call that when we are digging up oil from our storage, up storage, then after first petroleum invention to today's one, gradually we are increasing the amount of amount of lift from there. But that there is one equation we all know, we all understand that this trapped petroleum under our they are called as fossil fuel. Fossil fuel covers all, not only petroleum, it covers coal and other things also. But anyway, this petroleum, that is a finite amount of storage is there. Maybe some are already known to us, some are not known, but it is finite. Globe size is finite. Its amount of fossil fuel, trapped fossil fuel amount is also finite. Now, you cannot have one infinite growth with one finite globe. Not possible. So, some way we have to have alternative of this petroleum driven situation. Now, petroleum is a very useful one. Means you can consider petroleum uh, as a driving or as the parameter to understand one country's civilization growth also. That is also there. Okay. It is not that only transportation, but there are many other issues. But at least today, we can think of the replacing of the petroleum driven transportation by some other. Today, we are talking about electric vehicle. We understand electric vehicle, if the electricity itself is coming from grid, then it can give us very good amount of um, electricity very quickly and we can use it. But at the end of the day, once again, the same question may come that where from this electricity is coming. Okay. And maybe at the end of the day, you will come up with the solution that you are replacing one fossil fuel by another fossil fuel. You are replacing petroleum uh, by say coal. If I consider that most of the grid electricity are coming from uh, coal, then you will understand that 1% is replaced by that one. And your emission, which was distributed because you are running your car and emission is happening there, is now concentrated at the plant itself. Okay, so this may happen that we need to think in other way. We need to so that is not simple electric vehicle. Getting power from grid is the solution. Huh? So there are many other issues, but we understand that whatever may be the consideration, there must be a gradual decline. It is written a gradual decline in the popularity of fossil fuel powered IC engine. You must be reducing this. Excuse me. Now, when we are going for one transition from IC engine based vehicle to battery electric vehicle, we should be aware that all of a sudden you cannot have that one. You are having IC engine based vehicles and IC engine or internal combustion engine vehicle ICEV is written here ICEV. Now you cannot just go from ICEV to EV electric vehicle. It is not that easy because the application demands many other issues also. Okay, so how to tackle these issues? How we can transit gradually from IC engine to the electric vehicle, to the electric vehicle, because uh, there are many issues. We will come to that one. But at least, as I am telling, it is a transition from ICEV to EV. The transition is proposed by hybrid electric vehicle. It is kind of a combination of IC engine and battery electric vehicle. IC engine driven uh, vehicle and electric motor driven vehicle. Okay, it is kind of combination of these two. This is the hybrid. First term came hybrid from there. Hmm. The advancement in electrified powertrain technology, it helped us to have a lower cost in the HEVs. Yeah. So the first reason was the basic problem was that the HEVs were initially costly. You are already having IC engine, they are adding one more component. So there may be some problem. But gradually the powertrain is developing and we are finding that HEV is becoming competitive. We will see that how much competitive it is later. We'll check that one also. Now we know the HEVs price parity, it is written price parity, will be same as ICV by 2024 and will become cheaper by 2025. It is the prediction made on 2014. The initial this prediction came in the year 2014. Now we know that it is today the hybrid vehicle are really very competitive, and means by before 2024 only, even electric vehicles, fully electric vehicles are also coming in that range gradually. Gradually, it is coming down of similar capacity. Still, electric vehicle is costlier, but it is coming down gradually. The electrification within vehicle can take in different form. These mild hybrid, strong hybrid, plug-in hybrid, and fully battery hybrids. These things we will discuss. That what are the how they will be classified. These things we will come to that one. But we understand now that electric vehicles are having one flavor. We already knew the IC engine based vehicle was having another flavor, and IC engine vehicle is known to all of us. Electric vehicle is also getting on kind of familiarity already. For last few years, it is in the domain of academics and research, um, very much in India. So most of you are aware about that one also. So it is just one scheme which is telling us that what are the components of the electric vehicle. Just to um, give some relief that well we need one electric machine and will be driven by battery pack. The things will be battery energy stored in the battery will be utilized by the machine through inverter, and energy will go to the battery through charger. And there must be some DC-DC converter which can um, allow the transition between low voltage and high voltage battery pack. Okay, so this is the different components. Just it is just a scheme. Do not consider that things are placed in this way. Means inverter is here. Not that this is the scheme. It is telling us what are the possibilities. Now this charger, you remember the first figure or picture we are showing is this charger which is getting supply from the outside. Now this is a scheme available right now. Let us know a little bit of the state of the art. What is happening with hybrid electric vehicle? Right? It is developed to overcome the disadvantage of both the ICE and purely battery powered vehicle. And what is actually that? That is, I think I have put that one somewhere here. I have no details, but it should be something like that. Is the advantage, disadvantage there. Now, but how much energy you are putting, which it is a packet of energy. Battery powered vehicle is running with one packet of energy, and gradually the size of the packet is diminishing when it is going uh, through the road. Now, how long can you use that one? Not in terms of time only, in terms of distance also. So, what is the driving range? How quickly you can accelerate? How much load you can take? All these issues are very much tiring to battery powered vehicle, because if you want to address them really in the range of IC engine, then the main problem will be that you have to have a huge battery pack. Now, huge battery pack will give you definitely very high amount of energy storage, but it will take your space out. Your vehicle space is occupied by the battery mostly. A big amount of space is going to be there. It will be adding high amount of load on the engine. So, in other way to increase, when you are increasing the range, you are actually decreasing it also. So it is not that very easy. You are decreasing some facilities. Yeah. And it is not just one standard equation you can find out finally at the end of the day that I must have this much battery storage. Hmm. Because we all know that the limitation, it is a very complex problem and the limitations are very high. In that sense, the hybrid electric vehicle can overcome till now, as long as we are talking about transition, it can do it. Okay, I'm talking about transition. I must make you clear one thing. Do not consider right now. Do not consider that we are going or looking for or targeting for uh, removing completely the carbon dioxide emission. That is not the target. If that is the target, there is no point of discussing these things with help of technology here. You know why? The main reason is that you can remove, you can really go to that era where the carbon dioxide emission will be very low, which can be easily um, managing the no generation of extra heat by the earth. It can be only possible if you stop all the industrial activities. So technology and industrial activities are to be stopped completely if you really want to remove these extra carbon dioxide emission. So not possible entirely, but we can take one target that you can reduce it. Entire removal or absolutely sustainable future is very difficult. At least as of now, we cannot see it a sustainable future. But what we can do, we can manage our activities so that um, so that some imminent problems can be addressed quickly. One one report is there available in internet. It is called Summary for Policy Makers, but this will be recorded so you can check it. Summary for Policy Makers. The report came from IPCC, Intergovernmental Panel on Climate Change. There it has been told that by 2030, okay, by 2030 we have to reduce the carbon dioxide emission by 50%, not 100%. Huh? 50% reduction must be there in order to increase the temperature from 1990 level. What was the temperature at 1990? From there at 2030, the temperature will be higher by 1.5 if you reduce it by 50%. But if you do not reduce 50%, if you reduce 25%, then it will rise to 2 degrees. And the entire report is showing us one future where if you are not adopting 50% reduction goal, you are adopting 25% adopting reduction goal, then what are the problems coming to us? So reduction is necessary and 50% reduction is the target. But even then, we are not sure. Even then, temperature rise will be there. And even then, some problems will happen with our globe, darling Earth. And their problem's length is not predicted. Nobody can say definitely that how long this problem will be there, even if we have reduced it, the carbon dioxide, because we have done lots and lots of errors already. All cannot be corrected, all cannot be reversed. Okay, so what will happen? Maybe some of them will be there with us for 70 or 80 years. The problem will be there for 70 or 80 years also in future. So, but in the coming 9 years, 9.5 years, we have to reduce the carbon dioxide emission by 50%. How much we are doing it personally is not actually the question. How much we are doing as uh, a group in cumulative way, in state level, in national level, that is the goal actually. Individually, we cannot address this problem. Individually, all of us must be aware about the problem, but solution will be coming from every sector, everybody. In this case, in this workshop, we are talking about one solution which can reduce the carbon dioxide emission. Reduction is not only, you can say, of 100%, reduction of 50%. Okay. So what is our target for hybrid electric vehicle is to reduce the pressure on the petroleum. First target is that we are reducing the pressure on the petroleum because the petroleum is uh, gradually depleting. The source is depleting. Okay, and ICE will be there, which will be giving us some extended drive range, and uh, it can a little bit recharge our electrical sources also. There are schemes like that, and the requirement of the storage size will be less if you have one IC parallel to that one. But always we will try to reduce the pressure on the IC. It will be required only for extreme cases. For short durations, they will not be IC will not be required. Okay. Now, hybrid vehicles, as I told at the beginning, that we are having four different so classifications are. It is having mild hybrid. This is mild hybrid. Sorry, strong hybrid, plug-in hybrid, and the fourth one is battery electric vehicle. It is not hybrid. Now, in mild hybrid, what will happen? This is having a electric motor, but with small battery pack. You have seen these cars, this picture, and you can search this for your interest, from your point of interest also. You can check how much battery support is there. Now we see that Toyota, this Toyota Prius, it is um, it is a mild hybrid vehicle, where it will be supplying the sorry this is the mild hybrid vehicle, where it will be supplying um, a short range of uh, distance for from electric only situation, not very high. That means in the as much as I can recall, it was 11 miles. So, but what it will do, it will reduce the pressure for smaller ranges. It is very useful if you are going for a short duration, just a 5 kilometer or 6 kilometer drive. You do that and make it and charge it. Okay, for urban use, with within a city or something like that, you can rely on the battery only most of the time, and if required, 2 3 or 4 5 kilometers are coming from the IC. So most of the short trips can be managed. That was the idea. And take it from any expert that the ranges, they are not fixing up arbitrary. There are many equations they are solving and coming up with these ranges. So before choosing this range 11 miles for Toyota Prius, they were doing a lot of study on the customer behavior, on the nature of drive from the customer end. And the solution is really interesting, that it is reducing the pressure on the uh, petroleum large in a large context. Means, though it is giving only a small part, but it is supporting very nicely. It is possible. But if you need a little bit extra from the electric side, then you will be going for strong hybrid. Now, in strong hybrid vehicle, uh, the battery pack is of larger size. They have a more complex vehicle architecture and physical packaging requirement than mild hybrid are more. They are a little bit. The complexity is little bit more. Yeah. And it is definitely improving in terms of fuel consumption. We know we know uh, that electric motors are very much efficient. Their their efficiency ranges in the top of 90%, whereas these IC engines are uh, varying between uh, 40 to 50% maximum. Okay, these are on the higher side I am talking about, but it is on lower side also. 34 35% are also readily available. So you are going to one high efficient solution. That is one thing. Provided, do not consider, right now we are discussing on reduction of the petroleum use. Later we will be addressing the climate change issue. First target is that we are reducing the petroleum, and we have to do it by 2024, and by 2025 we know that there is coming a day when petroleum will not be available readily also. This month readiness will be uh, definitely restricted for nation building and other issues. Because source is going down, it is getting costly, and many other issues are coming. But we have to be prepared. Now, plug-in hybrid vehicle, that is more or less same as the strong hybrid vehicle, but its battery size is little bit larger and it can be connected with the grid. Now, grid, when you are connecting with the grid, the there are other use of electric vehicles also available. Means not only uh, taking power from the grid, it also sometimes supplying reactive power. Sometimes it can supply short term during very high requirement of the grid. If it is connected with the grid, active power may also come, and it will gain in terms of money, because it is charging when the grid is having excess electricity, and it is supplying when the grid is having the high demand. So it can act as one external equipment. There are different policies with these plug-in vehicles. Hmm. In developed countries, it is there. We are also thinking in that way. Now, battery vehicle, I think, is not to be discussed very largely, because mm, mm, we already have said that we are moving to the HEVs. So, future is right now. The future is going in the hand of HEVs. Uh, from ICEV, we are going to HEV. From HEV, we will be going to full EV, and that EV will be powered by renewable. So that type of solution will take extra time. We will go there. We will discuss a little bit of that one in this presentation also. We'll touch that issue, but the full discussion definitely will follow some more detailed footprint on the power electronics converters and other issue. We'll see that. The design approach for designing an electric powertrain to optimize energy consumption will be there. We will see it will be there, because lots of approaches will be coming, lots of different type of design will be coming with this powertrain. So powertrain, you can see, if you can search with powertrain, you will be getting many literatures, mostly from other countries, not from India. But we are finding, we are in the academic world, we find in academic world the advantage is that you can see, you are open to do any research, not like corporate research you are targeted to do one thing only. Yeah, here you can check, you see the powertrain, the improvement in the powertrain are happening for different ends, from different ends, from electrical engineering end, from mechanical engineering end, from materialist uh, I mean, metallurgical engineering. So there are different ends are there, which is this powertrain. Oh, and right. This is also one issue. The right comfort. These are important for future. We must talk about them when we will be having on futuristic vehicle. Now, these general requirements were applied to the subsystem level. Means every small subsystems will be improved, so that you will be getting the full system is uh, serving your purpose. It is giving you good power performance. It is asking for lower energy consumption and giving you the proper right comfort. Multi-objective optimization. There are different issues. One solution is showing that lightweight ratio of 93.5% and motor efficiency of 92% are the futuristic vehicle. Most will be accepted by manufacturers. Now, when design will be coming, so I have crossed 10 slides already. And I'm talking from one end. So, is it reaching everybody? Uh,
Yes,
are you
sir.
getting the idea? Okay. Means things are gradually opening up in front of us. I told you at the beginning that I am also learned in this field, because things are changing every day. So we have to have uh, opening always there in our mind. Now, when we are going from design to realization, then this is one schematic where requirement is specified, defined. Then you go for software modeling and simulation. These things I will be telling little bit today. Then prototype will come. The software in loop, hardware in loop will be implemented. You will be having one prototype with good amount of hardware and other things. Then code generation and validation. Finally, from design to realization. These are the steps you have to take as engineer or technocrats. Now these are the schemes now available, common architectures in hybrid electric vehicle. This is a very simplistic way we are presenting the schemes. This first one is series hybrid. Series hybrid means this is the T is for transmission, means the mechanical transmission. It is having brake, it is written here, huh? Transmission including brake, clutch and gear. Okay, finally, it is the traction will happen with help of this transmission. Now, this transmission is actually getting supply from this M. M is the motor. In series hybrid, the electrical motor is the one who is actually driving the car. And this motor is supplied, the electric power will come from the battery through the converter. P is the power converter. Yeah. So basically it is BPM which will be working. But also as it is hybrid, series hybrid, you can see the fuel, it is the fuel tank and this is the engine, IC engine. It is combined, this fuel is utilized by the engine to run the generator. G is for generator. It is generating the electric power and that is regulated and managed by the converter to supply the motor. So it is coming in line, okay, but it is also supplying the motor. The same motor, one motor actually, if this motor is having any problem, both IC engine and battery cannot solve it. Okay, so it is kind of, that's why it is called series. Otherwise, you may say it is a separate line, it is a separate line, but up to this they are separate. But finally, to traction, only one man, uh, one machine is supplying the power. Okay, that's why it is series. And the next one is parallel. It is the most popular one, parallel one, where but it is also difficult to achieve because the traction will be supplied uh, by IC engine one way and also by electric motor. So some way you have to make one off or clutch it, uh, clutch it. One will be in operation, another will not be in operation for some time. As long as your battery power is there, you are supplying this one, and when it is not there, you are supplying through fuel line. So, but definitely you have to have some extra mechanical arrangements to switch over from the motor to IC engine, and which will, if mechanical arrangement is there, there is a chance of getting a little bit maintenance problem. Huh? Whenever it is electrical thing is little bit less uh, prominent to maintenance, little bit. Huh? Excuse me. Now, this is the series parallel hybrid and complex hybrid. They are more or less same, but it is there in series parallel hybrid and complex. In series parallel, you see the fuel and engine is driving the traction. BPM is also there, FE is also there for the traction. But there is one complex line which can, means fuel can charge the battery also. This fuel can charge the battery also to this generator. This extra line, either you charge it directly through the same power converter or you use another power converter for the charging. So it is the charging line, and discharging line is same BPM in both the cases. So they are more or less same, but depending upon the configuration of your power converter, maybe this is not sufficient. Then you have to have a different power converter for this. But these are the popular structures, architectures for your hybrid electric vehicles. Now we understand this is the scheme of putting E and M. Finally, they are the drivers, IC engine or the electric motor. But in the powertrain, when you talk about the powertrain, we will see the difference is there. What is the difference? It is showing, the powertrain is showing, it is um, one scheme is called PO or P0. There are two powertrain architectures which are already approved by Eco Car organization. These are P0 and P4. They are good and they are approved, and manufacturer will be looking for either PO, P0 or P4. Normally they will be working with this one. Okay, and we see what in the, this is the architecture for PO, P0. Okay, this architecture. It is showing what? It is showing the motor which is connected with the battery, the motor and engine, I say engine, they are connected with a belt. Through a belt it is connected, and both of them finally can drive the front wheel of the car. Okay, this front end accessory, both the wheels can be accessed by this engine and motor combination. Okay, and they can do whatever they have to do with this end. This is the structure called powertrain structure called P0. Another structure is P4. This is the P4 structure, where the IC engine is in the front end and electric motor is in the rear end. Okay, and definitely when you are running the electric motor, you are not running the IC engine, and vice versa, because there must be some kind of synchronization. Otherwise, two cannot run at the same time. So we don't want that also. But we are putting either in front end engine and rear end motor, or both at the front end. So P0 and P4. This is the accepted one already. Now from there, we are showing one example to you. This is one example, and this example is very popular. Means it came after a few iterations, that how one can work. One fuel tank is there, which is utilized by the engine. Engine is 2.5 liter engine, and this engine is connected with your system, your front end, and motor is 150 kilowatt motor. Okay, so this 2.5 liter engine is written here as 148 kilowatt, and this motor is of 150 kilowatt. Okay, so and the battery is 132 kilowatt is connected here. So um, it is the scheme which will be today. We will see little bit how they can really um, operate in MATLAB Simulink domain. Hmm. Siemens will just discuss this one. Actual MATLAB model will not be presented here. Now, when you are preparing the powertrain uh, model in Simulink, you can see there is one Chevrolet Blazer. Yes, it is there in
काय केले
MathWatch. Okay. Is it okay? Am I audible?
Hello?
No, yes, sir. Yes, sir. You are
Mala,
audible, sir. You are audible, sir.
Okay, okay. Some other sounds came, I thought.
Participants, please mute your microphone. Please mute your microphone.
Okay. So what we see in MATLAB Simulink, you can mathematically model one complete powertrain. Okay, you have already available in it. So MathWorks is supplying this one, and you can run it. You can put some user-specific characters here, and you can run it here. And what are the different things? It is having one engine block, it is having one motor block, it is having one battery block. All these things are incorporated in it, yeah? And you can do it. Um, just a minute. Just a minute. Huh? I am having one right here. Now, when you do this simulation, what you will be doing? You will be giving the specification of your engine, of your batteries, of your motors, and everything you can fix up, and then you can run with one drive cycle. The drive cycle also you have to choose. The drive cycles are available in nowadays in all domain, all vehicle domain. You can see what is the standard drive cycles through which your model should be tested. Hmm. So you can check that one, and mechanically feasible designs are considered. Mechanically feasible means say 1.5 liter engine and 271 second are considered for the PO configuration, whereas 2.5 liter engine considered for P4 configuration. The sample I have shown you is P4 configuration, so it is taking 2.5 liter. But if it is PO, then it will be 1.5 liter engine. So these are the specifications, and these are available in domain, public domain. So you can get it. It is very easy to get it. Huh? And these matching electrical components also you have to consider. Understand? Because you are using a motor and you do not have the battery, sufficient battery and inverter power, then you cannot supply it. So that amount of supplement always will be there with you. Okay, and you should run for two different drive cycles. Now, um, here I am showing you one performance presentation, not the transient performance, but what we see, uh, five different configurations are presented. In one case, it is PO, so 1.5 power 271, and with the battery HDS. This is the PO. It is one configuration. But for P4, there are four different configurations. The 2.5 liter engine is must. That is the mechanical constant. You will be having all 2.5 liter. But the motor point of view, we can see here three different motors are used: AM EDU, ER Max 228, and 5 power 271. These are specified. Yeah? These are the motors you can take from the stock. There is one library from where you can take these motors. Yeah? They will come with proper. These are actually proper mechanical supplement with the GM 2.5 liter LCV. The battery packs can be uh, two different types: GM HEV4 and HDS. Okay, so it is one HEV4 with AM and HEV4 with ER Max, HDS with high power, and HDS with AM. Now, definitely GM HEV4 with 5 power and HDS with ER Max are not presented here. They were not satisfactory. Yeah? These results are showing you more or less satisfactory. Those two were also been tested, but they are not giving us the satisfactory results. So we are not putting them in this presentation. We are putting only those results uh, which are giving us uh, satisfactory performance. Only these red colors are showing here it is not satisfactory. This parameter is not satisfactory. 140, 139, 139. They are not satisfactory. They should be less, but it is higher. And fuel economy for this fourth one is also not satisfactory. But in other parameters, they are satisfactory. And the last one, um, do you want to say anything? Anyone? Okay. The last one is satisfactory for all cases, all 5 cases, 6 cases. We can present them here also. What we see, because why I'm telling satisfactory? Satisfactory means what? Means this is the competition target. Because when you are putting on HEV, you are competing the IC engine. Huh? And there it must be the acceleration from 0 to 60 mile per hour should happen within 7 seconds. That is the target. And this fourth one is doing it within 4.78 seconds. The acceleration from 50 to 70, it should be within 6.5 seconds. We find it is 4.15. So within that. The braking should happen at within 138.4 from the highest speed. In this case, it is happening within 135.5. So it is less. Remember, in the last table, for some cases it was more than 138.4, 139, 140, like that. The total range should be more than 250 miles. If you have a full tank fuel, then you should be more than it should run more than 250. It is the normal range for four-wheelers, IC engine based. Here, this hybrid will take you to 308. The combined fuel economy mile per gallon, uh, it is as it is US 4, we are getting that one mile per gallon, but you can convert it to kilometer per liter. Okay, and they are very important. Huh? Is telling you 33.5 mile per gallon, and it must be more than that one, and it is showing you 33.8. And emission is very very much low. It should be less than 373, where we are finding it is 43.7 only. So from emission point of view, we have reached, means matching all the criteria, driving comfort, economy, because it is fuel economy is high, matching or meeting all those criteria. We are also receiving the situation where you can reduce the emission uh, a lot, a lot. Okay. Now,
सारी बहुत अच्छी चीजें बता रहे हैं लेकिन हम देख नहीं पा रहे सारा रिकॉर्ड जाता है कॉपी से ठीक है ना ये चलता रहेगा
um, should I continue? I think participants, please mute. It is written. Well, I hope they can understand. Okay. So I was actually showing this one. No? Now, from at this point, I want to take a break for all of you. So, what you have seen so far? You have seen. I'm repeating. We are observing one range of vehicles which are available already. Variety of vehicles are available, out of which we are discussing hybrid electric vehicle, and hybrid electric vehicle structures are shown here. From there, two powertrains are placed which are already been accepted, and from there one um, one powertrain is selected with some rating, which is also presented in this case the same one. This one 2.5 liter and AM EDU is this one. This is the same thing. 2.5 liter and AM EDU. This is the one. And when we run that, we see it is meeting. It is uh, meeting all the criteria and reducing the emission. Up to this is the first half of your presentation where you are talking about hybrid electric vehicle to reduce your emission. Okay, this you have achieved, and it is achieved means it is you can, all of you can do it in your home only using your MATLAB. You can see it is working. This model is working, and you are getting on confidence. Well, hybrid electric vehicle is nice. Yeah, that is for one academic exercise. Anyone can do that. But the tougher task is that how to address the other issue. The issue is how to reduce the carbon dioxide emission also from the central point. It is reducing the emission from the vehicle, because the IC engine and from the motor there is no emission, electric motor, but as IC engine is there, it is giving, when it is working, it is giving some amount of emission. That is the reason it is there. But if you consider the actual case, the power is generated by fossil fuel, then definitely there will be some bitter truth will come to you that emission is happening at the power plant itself. So the next step is that you go for hybridization in electrical energy storage also. Clear? And you will run in a way so that your electrical energy requirement will also be less. Okay, and maybe a part of electrical energy will be coming from a renewable source also. Means you are having a battery, very good battery, fine. This earlier one is sufficient. But with the battery, if you are putting some other type of storages also, and if you can manage them, then you will find beautiful advantages are coming to you. We understand it is making the system more complex, but we understand the situation demands for it. Okay, means earlier it was a simple IC engine. Then what we proposed, reduction of the fuel by putting one electrical motor. Then what we are proposing, that the electrical energy supply for that motor is not should not come from the battery only. It will have little bit of combination. Then one converter which was taking from battery to the motor, BPM, battery converter then motor. This converter is not dealing with battery only, it is dealing with other sources also, and control, extra care, extra management of those sources are necessary. Clear? So, what we are telling first, that our storage should be having sufficient energy to, because we have already seen there is one specific requirement, so that will be there, sufficient energy, and it should provide adequate peak power. You are replacing battery by somebody and that is not having the power density, then it will be very difficult. Then you cannot expect that it will be accepted by anybody else worldwide. But the reason is clear to us that we if we do this, we may have some extra advantage, added advantage over the earlier one. This one you will not find in your ready MATLAB model. For that you need to do something else, because here some contribution will be there from you also. Now this is the situation right now. This is the situation of different storages. What are the storages I have shown here? One is this ultra capacitor, one is flywheel storage, One is electrochemical battery, which is coming in between, and fuel cell, and finally gasoline is not storage, but you can have it. You can have the gasoline there. Hmm. Now, what we see, the energy density is high with fuel cell, but its power density is low. Okay, and for ultra capacitor, power density is high, but the energy density is not that high. It is only in the range of 1. So you cannot go for ultra capacitor for long ride, or you cannot go for fuel cell for high acceleration because its power density is low. So some combination, you can understand, this where you should have some combination. Okay, here if you see the same thing as specific energy and specific power, same one. Yes, power wise your capacitor is very good, but maybe energy wise it is very low, so it can give for a very short duration only. So for short accelerations, for short requirement of high power, you supply through the ultra capacitor, and otherwise you supply it from the battery. So it will be helpful to you. So this combination will reduce the size of the battery. Otherwise, this high power requirement, if you want to supply from the battery, which is having the lower power density, you have to have a very large battery bank. But they will be underutilized because this high power requirement will come only for short durations. They will not be there for the entire drive train. So why to bother? For short durations, you can bring that one. Just like initially you put battery for short range. Now you are putting ultra capacitor for short high power range. Clear? You understand that how we are moving from the earlier uh, age-old IC engine based vehicle to these new futuristic vehicles. There you will see a completely changeable, a very beautiful uh, problem, mathematical problem, challenging problem is there for you to solve. You solve it and you have a very nice one. It is open, wide open. We all are learning, so maybe anytime you will see a very nice presentation will be there from your end also. Okay. Now we are comparing between different things, battery and fuel cell and ultra capacitors, and we see a fuel cell is an electric energy generation type. A fuel cell combines oxygen and hydrogen, and battery is electric energy storage device. And on the other hand, the okay, sorry, I think these are the different energy storages. Means it is the battery bank, it is the ultra capacitor bank. If you combine these two, uh, battery or fuel cell, it is up to you. What is available? But they are in the same category. They are more or less in the same category. You have to choose which you will be taking, battery or fuel cell. But after that, the high power will be coming from the ultra capacitor. This is the combination. If you are say running a match, huh, your you need two openers. Nah, one cricket match, two openers. One is fixed. Who will open the match is fixed. The ultra capacitor. Acceleration will come from it. But the other one, the energy storage may come from any one of battery or fuel cell. Okay. Excuse me. So after that, we are checking one possible proposal. What will be this proposal dealing with? That it is telling us that uh, it will be having one brushless motor, permanent brushless motor, or induction motor, whatever may be there. This will be the motor. Huh? And this motor will be utilizing the hybrid type of sources. What are the sources? We are coming to that. But the control should be developed for this one, because if it is permanent magnet motor, one type of control; if it is induction motor, another type of control. Because these controls are necessary if you really try to address the hybrid electric vehicles targets. And this is one scheme. This scheme is telling us that one multi-input converter is presented here, where you have battery bank, you have ultra capacitor to supply this DC source. But in addition to these two, you are having one input photovoltaic panel also, which can be there on the top of your car. It is not that the entire energy will be coming from this one, not that. But just like this transition model, it will be reducing the CO2 emission from that centralized source also. Earlier, what we have done? We have reduced the emission at the distribution level from petroleum shifting to electric, and we are finding reduction of emission is there. But if the electricity is produced by hydro power, wind power, or solar power, no problem. But if it is produced by once again gas or coal, then it is really not helping you. So what we do? We put one as much as possible. Your car will not be the final solution, but as much as possible reduction will be there from the central energy source. You can charge it separately. Charger will be there to charge your battery or ultra capacitor. But the PV is there. It will be giving you some amount of power, at least during the daytime. Some amount of energy will be captured by the PV, and if your car is not running, it will be charging the battery and ultra capacitor. If your car is running, it will be supplying to the car directly, motor directly. And so less amount of power will be coming from the less amount of energy will be coming from the battery. And in ideal condition, you already know, I told you for Toyota Pyras that your driving range from the battery is 11 mile. I told you, na? Now 11 mile with the battery bank, and within these 11 mile, some short durations covered by the ultra capacitor. Toyota Pyras is not having ultra capacitor. You are adding it. If you are adding it, your battery requirement will be less. Your same battery pack will now be ready to give you extra mileage, not because of ultra capacitor mileage, because of the reduction in the capacity of the uh, battery was happening for the accelerations, which will not be there. Now the acceleration will be tackled by the ultra capacitor only. The battery will be saved, and it will give you extra distance. But it is, I told you, it is a city ride kind of thing. After all research, it is city ride 11 miles. So maybe our um, consumer is running for 5 kilometer or 10 kilometer at a stage and reaching his or her destination, and putting the car just there for the day, whole day. And after the office is over or his business is over, coming back to the car, by that time the car is ready with help of solar, is ready for another uh, 11 months. Okay, so you can have that one, this kind of thing. As much as I can remember, Toyota Pyras is having a battery less than 1 kilowatt hour. Oh, you can check the specifications are available in net, not available in my presentation, but it is available in internet. It is less than 1 kilowatt hour. Idea is that some of you are having, definitely having maybe home UPS or home inverters. The batteries, usual batteries, are in the range of 150 ampere hour of 12 volt. So the inverter battery itself is 1.8 kilowatt hour, and your four-wheeler battery is less than that one, less than 1 kilowatt hour. So your PV, if your PV I'm giving you one small calculation help. Do you have any idea, please, before we, because choose how this power electronics converter will run, what will be the control, those things we will discuss, may not be completed by today, in next 15 minutes already, um, only. So better let us do some mathematical exercise here. See, your battery, let us say you are running a Toyota Pyrus with this battery bank. Huh? Your battery is of 1 kilowatt hour. Now, can any one of you tell me that if you really want to store 1 kilowatt hour from one solar cell, what should be the watt peak of that solar cell in a day? In a day, you want to charge it. In 6 hours, you want to charge it. 6 to 10 hours. Eh? Though they are telling it is 12 hours, morning 5 to evening 5, but it is not really true. Energies are not available for the 12 hours. And say it is 10 to 6 to 10 hours. But maybe your solar cell rating, which can charge 1 kilowatt hour battery within this 6 to 10 hours. Any idea about sizing of photovoltaic cell? Anybody? No idea. I cannot see. Let me see from here. How many participants are there? It is showing 110 participants are there. So I feel quite a lot of you are there. You should have given me. Anyway, I'm helping you. Huh? Maybe you are aware of it, but true. Sometimes in this forum, it is told as 1 watt peak PV. Thumb rule is that 1 watt peak PV in 6 to 10 hours can capture 4 watt hour energy. Here, 4 watt hour energy. So if you put, actually it can, if you take the fragments of the morning and evening, then maybe it will be capturing 5 kilowatt hour also, maximum. But 4 is standard. So now to charge 1 kilowatt hour battery, your PV should be up to 50 watt. 250 watt will be giving you, 250 watt peak PV will be giving you um, 1 kilowatt hour at the end of the day. Now, 250 watt peak PV, how much area it will take? Because you are putting it on your uh, car top. How much area will it take? Do you know? Any idea is there? This area versus wattage of PV panel. Not a very smart PV panel, normal, regularly available PV panels. They actually take, the thumb rule is that 100 square feet for 1 kilowatt, 1 kilowatt peak. 100 square feet for 1 kilowatt peak. So 10 square feet for 100 watt, you need 25 square feet. 25 square feet for 250. And if your car is having 8 by 5 feet, 8 by or 7 by 5 feet uh, roof area, because it is a very, even a smaller car nowadays are having 7 feet by 5 feet roof area. So 35 square feet is there, and you need only 25 square feet to serve your battery. So you can have it. Solution is readily available. Just you have to manage this inverter or electronics inverter. If you are ready with this inverter and control, if you're a little bit conversant with the inverter and control, you can make your car much more smarter than one Japanese Toyota car. Okay, it is possible. It is possible. Now this is the charging path. I'm not going in details. We will go in that details in later parts. So I'm quickly telling one flowchart and closing this one, we'll be having many other issues left for discussion, because management of three different sources, the development of the control and development of the to understand the switches and their issues will take definitely a little extra time and little deep insight of the for electronics situations. So we'll go to that one, that end also later, not now. This is one brief idea, brief introduction where we are coming in the domain of hybrid vehicle. And from hybrid vehicle, we are making the electric power also hybrid, electric energy also hybrid. Now, this is one very simple way to present what it is telling us, that if my solar, it is how you are choosing, not the transient thing. It is just the choice. How you are controlling your switch is different, but which mode will be used? You will be charging the battery or you will be discharging the battery. You will be charging ultra capacitor or you will be discharging ultra capacitor, or you will be taking power from the PV or it will not be taken. Will the PV is having one maximum power supply situation? Is it work with maximum power point tracking mode, or it will be running with a lower power point tracking mode? These are the three different combinations. That is, your PV can give maximum say 250, but your requirement is right now your battery is almost charged, capacitor is almost charged, vehicle is standstill. So what we can do? We will not take 250. We will take little less than that. Hmm. And so two-way, na? Maximum or less than maximum. Battery two-way. Either it will be charging or it will be discharging. Ultra capacitor two-way. Either it will be charging or it will be discharging. So all of these three are having two different states. Now out of these six, which one we are choosing? We are telling solar radiation is there or not. If it is no, then no option. Nobody is charging. Either battery is supplying or ultra capacitor is supplying. Okay. If your state of charge is there, that is battery is available, then battery is supplying. Yes. And ultra capacitor is also supplying for the acceleration. Yes. If the battery is not available at that time, only ultra capacitor is supplying. That is the idea. It is for no solar irradiation. It is the evening situation. You are running, your solar is not there. You are driving the car with the battery and ultra capacitor from this side. And if the solar is there, then what it can do? It will see that load, गाड़ी चल रहा है कि नहीं, is it running or not? If it is running, then power available with your PV is more than load or not. If it is not running, it will be more. If it is running, it will definitely not be more than that, because PV is less. Your power is requirement is 140 kilowatt hour kilowatt, and PV is of only 250 watt. PV definitely, if the car is running, it will be no. If the car is standstill, it will be yes. Okay, but solar irradiation is there. PV is not more than load, true, but PV can charge. We can charge we can work in MPPT mode, and it will charge the battery and ultra capacitor. Okay, it will charge. But if it is if the car is in standstill mode, PV is more than P load, then definitely it will check. Okay, should I charge battery or should I charge ultra capacitor? Or should I charge both? Or if SOC is less than the lower limit, then definitely it will charge the battery. If it is not, then it will charge the ultra capacitor only. Okay, PV and ultra capacitor. If the battery is requiring charge, if SOC is less, then PV is charging and battery is if PV is supplying the charge and battery is taking and ultra capacitor is taking. So these are the different modes of operation. So with this, I'm not going in these details. Later I will see. I am concluding that while the electric vehicle market today, it presents huge opportunities for manufacturers, but they have to overcome significant hurdles. Okay, profitability should be there, usability should be there, sustainability should be there. So there are different ventures, different manufacturers are trying to cope with the situation, and it is very hard, very tough. Believe us, uh, very quickly solution will not be coming, but if we try, it will be there. Fine. Okay. So with that, I must thank to all of you, and now I am open for any question if it is there.
Thank you, sir. Thank you very much, sir.
Okay.
So,
So
do you have any
question is,
questions? You can ask, sir, now.
I think it was a long duration, and after, yes,
Yes,
thank you.
yes, sir.
Somebody in chat written thank you.
Yes, sir. Yes, sir.
Actually, after lunch, na, people want to take rest, and during rest
Yes, sir.
time,
That's true,
you
sir.
are asking them to run a car. I understand that it is a very difficult
Good
situation.
morning, sir.
Yes, yes, thank you.
I'm Shruti Sharma from West Bengal.
Yes,
Sir, sir, can you hear me?
yes, Shilpi, I can hear you.
Sir, bidirectional chopper can be used for hybrid electrical vehicles. Is it suitable?
Bidirection will be required. It is definitely you are correct. Bidirectional is required. I have not shown this operation fully, but those converters or that multi-input converter what was there in the presentation was bidirectional. Otherwise, how battery will be discharging and charging through one converter only? I'm
I have
telling
one
battery
more
will be
question.
charging and battery will be discharging from the same converter. So it has to be bidirectional. True, bidirectional is required. True.
What
And we will be
kind of
discussing the detailed power electronic operation of that chopper or by converter, DC-DC converter in our next session.
sir, what kind of controller will be more suitable for bidirectional chopper?
That is really one uh, tough question. Very very. Uh, is there any echo from my voice?
I think someone unmuted.
If others can unmute, I think it will mute. If others can mute, it will be helpful. Anyway, the trick is that when you are choosing the control, you first have to understand that you are having so many sources, you are having so many objectives, hmm, and initially the flowchart what I have shown you that it will work or not. That's the idea only. If you will be in MPPT or not. Battery will be discharging or charging. But when it is charging or discharging, there will be some transient goals also. And those transient goals cannot be achieved by this flowchart only. Flowchart will be giving you one set point. But are you reaching to that set point or not? That can be oh Baba. It is echoing from someone's computer. Anyway, uh, uh,
Switch off your
that
microphones. Please switch off your microphones.
that can be achieved. Most of the or the best suitable one will be advanced control methodology. Normally, we power electronics engineer for electronics switches. The best one is sliding mode control. Best one, okay. But we have to see. Well, best one I'm telling, but maybe some other adaptive control or any other control methodology will be suitable for this MIC, because MIC are having different difficulties. Some interaction between inductors are there. So question is tricky. I'm telling you, there is no direct solution, but depending upon your available resources, their sizes, and your drive cycle, you have to come up with the best controller.
That
But as of now, sliding mode control is the best one.
sliding mode controller is non-linear controller. If I want to
Yes.
apply linear controller, then hysteresis or peak current mode controller can be used for.
See, one thing you understand, power electronic circuits are non-linear. Na? Power electronic circuits are not linear.
Yes.
This is the uh, whatever, maybe it is one simple diode. There is no other thing, one diode. Then the circuit is becoming non-linear. So, so when you are using one highly non-linear circuit, you have to do, if you are implementing linear control, you have to do lots of approximations. Linearize your circuit. You can linearize with some limitations, with some approximations, but best way is do that without approximation. If you can achieve without approximation, it is best. If you cannot, please then go for uh, uh, non-linear control. Non-linear control is better, always better. But I understand that it is a little bit complex. But once you develop, you take 2 months extra to develop that one. But then it will be very much effective. Because nowadays, our controllers which are connected with the real-time systems, they are all digital controllers. They are not analog controllers. No? You use DSP, FPGA, microcontroller. They are all digital controllers. So as digital controllers can accommodate non-linear control very easily, it is always preferred that you go with the non-linear controller if you understand the control. Okay.
Thank you, sir.
Yes. Thank you. So, sir, should we call it a day?
Yes, sir. Yes, sir. Yes, sir. Yes, sir. It was
Okay,
a
sir.
nice,
Please send somebody.
nice.
Somebody will. Sir, please send feedback. Oh, I think it is.
Okay, sir. Okay, sir.
It
I will do it. I will do it,
forwarded.
sir. I will do it.
Okay.
Yes.
Thank you, and have a very nice workshop ahead. This is the first day. We will be having
Yes.
lots and lots of things coming for you. Thank you. Thank you, Shantanu.
Thank you,
We'll be
sir.
meeting
Thank
later.
you very much, sir. Thank you very much, sir. Okay, sir. Bye, bye.
Welcome. Bye.
Record, 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 record. Stop.